Hi, this video you should have been solving inequalities recently, and so we have talked some about when we use inequalities, when there is a range of acceptable answers, not just one number. And so remember that inequalities compares two things. We have our greater, our less, greater than or equal to, less than or equal to. So for these word problems, we're going to need to know a few other things. One of those things is we need to know about cost. So when we talk here about cost, we're talking basically about expenses. All right, so what the person in the problem is paying to create a product, for example. Revenue is our sales. So you might think of revenue being the sales or income. So that's the money you have coming in. And then average, this is also called the mean. And to get this, we add all the numbers together and divide by the number of numbers there are, by how many numbers are in the set. So those things are going to come up not in the same problem, but those things are going to come up in the applications that we're going to do. So you should have this, and you should have these same things. And so just in case you missed this, you have a way to go back and pick it up. So some pretty straightforward ones, just like not entire anything we have to solve, but just getting things set up. We might have something like at least, and this should be in some of your other notes, but if Bill is at least 21 years old, then that tells us that Bill is greater than or equal to 21. If we say at most 5 students drop the course, or we say no more than 5 students, or 5 or fewer, so at most 5 would be x is less than or equal to 5. The most part is the 5. That's why it's open to the 5. If someone's earnings cannot exceed $1,200, then they must be less than or equal to $1,200, right? Because $1,200 would be okay. So x is less than or equal to 1,200. And of course, nothing magical about x. I could have used E for earnings and S for speed limit, all sorts of things. In this case, though, it's not a speed limit. It said the speed must exceed. So exceed means we need to go over 15. Can't be bogging everybody else down by just riding your bicycle on the interstate. So the speed is greater than 15. And it says it must exceed it, so 15 itself would not be acceptable. It has to be over that. So it's what we do not need the equal line. Spot's weight is less than 50 pounds. Now the equivalent form there is blocked out because this one's already pretty obvious. We would just say x is less than 50. Boston is more than 200 miles away. More than, like greater than, so Boston is more than 200. So something over 200. X is greater than 200. And then this next one, if it's between 90 and 100 minutes, that means it's more than 90 but less than 100. So we could write two inequalities, but we have talked now about compound inequalities. So we could actually write this as a compound inequality. If it's more than 90 and it's less than 100, that means the x is between those two. And then we just need to get our symbols going the right way. So more than 90 means that the 90 is smaller, the x is bigger, and less than 100, x. So if I just look at the left side, that says that 90 is less than x, which is the same thing as saying x is more than 90. And if I just look at the right, that says x is less than 100. That's the easier one to read. All right, so that gives us just a little bit of background information. Some of those type of things we did when I first introduced you to inequalities. Okay, back side of your page, focus question 1. So now we have a chance to do like, oh wow, we've got lots of things, lots of information here. So these are ones that talk about cost and revenue. So Shauna sells t-shirts, and it costs Shauna $6.50 to buy each t-shirt. She also pays $150 every month to rent equipment so that she can put print on the t-shirts. And then when she sells the t-shirts, she sells them for $12. So it would seem like, well, she's making $5.50 on every shirt, but she also has to pay for that equipment every month. So we're going to write an inequality that can help us find how many t-shirts Shauna has to sell so that she makes a profit for the month. So that's what we're looking for. And so in this case, we're going to be bold, and I'm going to actually use T for t-shirts. And remember how I like to go through and things where it's like per shirt or each shirt, I'm going to give those things the variable. And in this case, we're going to use T, just to switch it up a little bit. So I see here that it says it cost her $6.50 for each t-shirt. So $6.50 is going to have a variable with it in my equation. And then I also see she pays $150 for each month. Okay, now we're only going to do this for 1 month. So here we go. And then, so that's only going to happen once, not for every t-shirt. And then she sells each t-shirt. She sells each t-shirt, and that's what I'm looking for $12. So that 12 also gets a T. Now, we don't always have to make this little T chart that you see next. In fact, later at some point you take an accounting class. Sometimes accounting they teach with this kind of a diagram. So cost in this problem, well, it cost her $6.50 for every shirt. So $6.50 for every t-shirt. And it also cost her $150 for the equipment. But that's not every t-shirt. Yes, it is every month, but we're only talking about making a profit in 1 month. So we only need to worry about $150 just like it is. And then on the revenue side, that's the sales. So that when she says she sells them for $12 each, it's not just $12 one time, not all the t-shirts for $12. Each one, $12 every time. So that's 12T. So then if we think about it, then here's what's happening is her to cost, her $6.50 for every t-shirt, plus, sorry, I covered up the plus sign, $150, and then our revenue is over here, and we're supposed to write an inequality, not an equation. If we wrote an equation, that would be when does she break even, not make money. So I want you to think about if we are making a profit, so if we have profit, that means that our cost have to be less than our revenue. Or we could write it that our revenue has to be greater than our cost. Right? We got to be making more money than we're spending. So in this case, if our costs are on the left, and we would not make money if it was exactly equal. So we want to use just the less than sign with no symbol underneath. The second kind of application problem we're going to see here is about averages. And so in this case, I see that we are looking for, I always like to go to the end and figure out what am I looking for. It says, what must the high temperature be today? So we're looking for a temperature for the average for the 3-day period to be no more than $100. So my X, I'm just going to use X since it didn't tell me something else. My X is my high temperature for today. So the last 2 days, so I've got a heat wave going on here, 102 plus 105. And then remember, if we're going to do average, we're supposed to add them together. Well, I have those two plus this day that we don't know about yet, right? We don't know what today's high temperature is yet. But that's what we're trying to figure out. After we knew all of those, we would add them together and divide by 3. And we want it to be no more than, so no more than must mean less than or equal to. Hopefully you left yourself enough space. So no more than would be less than or potentially equal to. So I know most of you don't like fractions, but let's kind of tidy up what we can in the top of the fraction before we do anything else. 102 and 105, that's 207. And then before we can actually solve the problem, start putting things from one side of the equation to the other, I would need to get rid of that fraction, because since it's a large fraction with more than one part, I need to get rid of it sooner in the problem. So if I multiply both sides by 3, now I have 207 less than or equal to, plus x, my bad, plus x is less than or equal to 300. Then we would be subtracting 207 on both sides, and we would have that x is less than or equal to 93 degrees. So if the temperatures have been 102 and 105, if the average has to stay under 100 or under, right, no more than 100, then today it could only get to be 93. It's currently 49 outside, so I think I'm in safe shape. All right, so that's an example with an average. So those are a couple examples that go with the work that you have coming up, so that you have those, and good luck. If you were in class, you probably got more examples than just those two.